This week, I wanted to answer the question, are my genes making me fat? Studies of identical twins reveal that the heritability of obesity ranges between 70 to 80%. This is exceeded only by height and is more significant than many conditions that people more typically think of as having a genetic basis. Although the link between obesity and genetics has long eluded scientists, we are starting to uncover many different genes that contribute to this heritability. Historically, genes promoting obesity were likely to have been passed down due to their advantageous nature during early society, increasing the likelihood of survival until reproduction and, of course, passing those genes on to the next generation. This can be seen in the way that some ethnic groups have a greater prevalence of obesity, independent of their environment. For example, native Hawaiians with a greater proportion of Polynesian ancestry in their genomes face a higher risk of not just obesity, but also type 2 diabetes and heart failure. These genes that increase the likelihood of obesity control factors such as the regulation of metabolism, satiety, appetite, addiction, and motivation to engage in physical activity. Not only do the genes we have impact our risk of obesity, but also how these genes are expressed. In addition, the environment an individual finds themselves in can impact the way their genes are expressed. For most people, obesity is due to a combination of genetic and environmental factors. However, specific genetic mutations in single genes have been identified as a major contributing factor for a small handful. Very rare, severe and early onset forms of obesity are caused by mutations in genes involved in the leptin melanocortin pathway, which regulates food intake and appetite. The hormone leptin, produced by fat cells, binds to leptin receptors in the brain, which tells us we are full and can stop eating. Leptin is coded for by the Lep gene, of which we should have 2 working copies, one inherited from each parent. The absence of leptin, due to a loss of function mutations in both copies of Lep, leads to severe obesity and increased appetite. This effect is still present, but not as pronounced in those with only one faulty gene copy. Mutations affecting other components of the leptin melanocortin pathway can also cause severe obesity. It has been estimated that approximately 3% of severe obese adults and children may have these mutations, which lead to feelings of hunger even when leptin levels are normal, a type of leptin resistance. One of the most common forms of monogenic obesity is due to a mutation in a gene called MC4R. One defective copy can increase the chance of obesity, whilst 2 defective copies appears to result in severe obesity in all carriers. Interestingly, specific mutations of the gene can actually be protective against obesity. A syndrome is a set of medical signs and symptoms correlated with each other and often associated with a particular disease or disorder. A clear link has been established between obesity and around 30 syndromes. One such example is Prader-Willi syndrome. This syndrome is a rare genetic condition that causes many symptoms, including physical changes, learning difficulties, behavioural challenges, increased appetite, and obesity. Prader-Willi syndrome is caused by some missing genetic material in a group of genes on chromosome number 15. This leads to a number of problems and is thought to affect a part of the brain called the hypothalamus, which produces hormones and regulates growth and appetite. Before we take a look at the next topic, I have a quick favour to ask. Suppose you found this video or others I've made interesting. In that case, can I ask you to take 5 seconds to support my endeavours by subscribing and liking this video? Doing this helps the channel grow, which means I can spend more time making higher quality content for you to enjoy. Copy number variation is a phenomenon in which genome sections are repeated. the number of repeats in a genome varies between individuals. Although typically benign, copy number variations have been implicated in various diseases, including obesity. One example prevalent in severe early onset obesity cases is the deletion of a 220 kilobase region of chromosome 16. Unlike monogenic forms of obesity, some copy variations have been found to increase the risk of being underweight as an adult. A polygenic trait is one whose phenotype is influenced by more than one gene. Although each variant may only pose a tiny increase in risk when multiple variants have combined, the risk of obesity increases exponentially. To date, we have identified approximately 60 different genes associated with obesity. However, the strongest association in many diverse populations, for both adults and children, comes from single nucleotide polymorphisms within non-coding sequences of the fat mass and obesity associated gene. Our food choices also appear to have a genetic component. For example, specific gene variants have been found to increase preference for dietary fat intake in young adults. Despite this, the current understanding of polygenic effects only explains around 2% of weight's estimated 70 to 80% heritability. We are making great progress, but much of this mystery remains to be solved. Epigenetics is the study of how our behaviour and environment can cause changes that affect the way our genes work. Unlike genetic changes, epigenetic modifications are reversible. This is because they do not change our DNA sequence, but they can change how our body reads a DNA sequence. Epigenetic modifications can regulate gene expression in response to the environment. The Lep gene, which we discussed earlier, is one example of a gene that's expression can be altered by the environment, resulting in increased risk of obesity. Epigenetic changes can occur whilst a baby is still developing within its mother. Those who receive insufficient nutrition whilst developing may have an increased risk of obesity in later life. Even the mother's nutritional status can have an impact, with those at an increased weight more likely to pass on epigenetic changes, increasing the likelihood of obesity in their children. As well as nutritional status, exposure to certain pesticides and antipsychotic medications can also increase the risk of obesity through epigenetic changes. Genetic variation affects the predisposition to obesity and the ability to successfully lose weight. For example, variants of genes associated with addictive behaviours have been implicated in obesity and the ability to resist food temptation. Managing one's calorie intake when meeting your needs may be one thing, but resisting the urge to eat when in a prolonged deficit can be more difficult. This may explain why some people can follow restricted energy diets without too much trouble, whilst others find themselves experiencing ravenous hunger after just a few days' restriction. Variants in circadian rhythm genes have been shown to affect dietary adherence and weight loss. In addition, they may influence energy expenditure in response to dieting. Genetic variants influence the degree of weight loss following bariatric surgery, meaning this intervention may be more successful in some for reasons far beyond their conscious control. So are we there yet? Obesity is a multifactorial disease resulting from genetic factors and lifestyle. Identifying rare genetic variations with strong effects on obesity has helped diagnose and design personalised therapy for early onset or syndromic obesity. However, common variants identified in recent genome-wide association studies currently have limited clinical value. Genetic testing in common obesity is more complicated. Some online companies are already offering direct-to-consumer genetic testing predicting common obesity risk. However, each gene variant identified to date only explains a small proportion of obesity heritability. Therefore, testing for such variants in clinical practice is not currently helpful for providing advice on obesity risk. More research is needed to discover the missing heritability and investigate gene-environment interactions. It appears the severity of the mutations, in conjunction with other genetic variants and lifestyle, determines the age of onset. So in summary, obesity-linked genetic variants have been identified in many genes associated with various traits, including satiety, food choice, addiction, physical activity, and circadian rhythm. A personalised medicine approach to obesity is already in development. It is expected to become more prevalent over the next 10 years. This approach will help clinicians identify relevant causal mutations or variants in their patients. This may eventually lead to a specific drug or dietary therapeutic treatment, enabling treatment where there currently is none. Anyway, that's it from me. I hope you found this video helpful or informative. And if you did, why not give it a thumbs up and consider subscribing. And before I go, this is your weekly reminder to never stop learning, because life never stops teaching. See you in the next one. Cheerio.